Hi, I'm Brian O'Leary with KIC. Meeting today with Jim Hall, TRW Auburn, New York.
The main goal for TRW to get into using KIC as a resource thermal management is, as you may know, that many of the components that are geared for lead-free are moisture sensitive, and they have a temperature peak range that you have to pay attention to. Given that fact, we have to monitor certain components on the board to verify that we're in compliant with those particular packages. Not to mention the higher operating temperatures for lead-free. We have to assure that we have tight controls on the thermal chamber itself. So those are probably some of the main reasons for why we use KIC with lead-free. KIC has met our expectations for both reflow and wave solder. The primary factors that we look at is the slope, the soak, the time above liquid, and the peak temperatures. All these are key factors to understanding how the product is being manipulated going through that process. And from a customer perspective, being able to explain these terms in layman terms, things that they can understand, they can see, it's very easy to explain it, these four factors, and visually show them right on the KIC screen how it all comes together. So for new product launches, it's been a real asset in terms of giving our customer understanding. So yes, it has met expectations. The main benefits, I would say, would be for engineers because of the ease of use for these tools. It takes probably about 15 minutes to run a profile through the machine, and being able to identify where your process is at. Meaning you can put in a specification for those four factors I mentioned, and just run one profile through the oven, and it'll quickly give you a feel for where you're at in terms of trying to dial in your settings. So what used to take me probably a half an hour or more to profile an oven now only takes like 10 minutes to run a board through under a certain set of parameters and lock in, and you're off and running. So the benefit for the engineer is if you're in a fast-moving market, which we are, you're constantly writing new programs or you're modifying existing programs. It's important to have the tools available, and they have to be easy to work with. That's key. I find these tools to be extremely easy to work with. It takes me probably no more than 30 minutes to take someone new on the line and show them the tools, and they have a really good understanding of how to support and maintain them. The thermal system itself, from an operational standpoint, is we can quickly go up and down the lines. We can quickly make assessments of when a product is encountering a problem. We can quickly rule out the thermal management side because KIC provides a history file that we can open up at a later date. We can barcode, we can pull that profile up, and we can verify that it was in compliance at the time it was built. So we can quickly rule out that reflow was either in or outside of process control. So that's been a real key asset when we're troubleshooting a board that has been returned from the field. Client benefits, they have been, again, they've been extremely good. I'm able to put a chart out by the machine with some basic terms for and how KIC is used and showing the profile system, and they quickly pick up and learn. But what they like is the 24/7 feedback system, which we're constantly plotting real time, everything that's going through the oven. So that's been a real benefit there. The business benefits have more to do with the level of field returns that have come to the shop, and that again we're able to quickly identify the source and where the defect was made. So we'll be pulling up a thermal profile immediately on a return board to verify whether or not it had any impact on the board in question. As far as improving the thermal profile, one of the things that we found early on with lead-free is when you get into certain percentages of rosin-based paste, what a lot of people don't realize is you can still have outgassing in the fillet, meaning you get voiding inside of a SMT fillet. And what that is you didn't allow enough soak time for the flux to volatilize out of the fillet, so you have a nice sound fillet. So we were able to put TCs on particular components, run them through the system, and do cross sections and X-ray to better understand the relationship of what was required to volatilize out all of that flux to make a more solid connection. I think that's one of the key players in SMT components, especially when you get into large body terminations such as crystals and J-leads and stuff like that. Process optimization related to process monitoring. We've, again, knowing the four fundamentals of reflow, your slope, your soak, your time above liquidus, and your peak, you're able to take all of your customer requirements. Some of those may be component driven, some of them could be right at the board level, some of them may be related to the type of solder paste you're working with. All of these have governing factors that you have to consider when you're putting a reflow process together. And being able to put TCs on particular sites in the process, we're able to home in on those customer requirements and protect those devices. And of course, the benefit of all that is you can go 24/7 once you optimize, and you get real-time monitoring. So I think the key is that you can establish a unique profile for each TC that you place on the board. You can put specific requirements on it. In our case, that's been real beneficial. Future considerations, we want to take this technology, as you know, we've already moved it into wave solder. We've learned a lot about wave solder, and the ovens in a wave are not as insulated as reflow, and so there's a lot of heat loss, and you can quickly learn with the KIC system through exhaust, making sure your preheat banks are positioned correctly, making sure that the hoods over your preheaters are tightly insulated, you got no gaps. We found that all of these factors together can cause your thermal profile to vary considerably. So we've since then added this technology into wave, seeing that we have moved in the direction of lead-free, knowing that the thermal requirements for wave soldering with lead-free is more critical to get good capillary reaction. And we're also now looking into selective solder, where we want to have the same types of controls where we can measure preheat as well as contact time in solder.